Okay, I'm going to work a practice test for the Unit 1 recovery. So starting with problem number 1. Let's take a look at what we have here. We have a division, addition, multiplication. So by order of operations, you have to do the division and the multiplication before you do addition, and we will work from left to right. So the division comes first. That would be 2, and then we would have plus 2, plus, and now we have 4 times 6 would be 24. Working from left to right again, we would have 2 plus 2 is 4, plus 24, so the answer would be 28. Next problem, we're going to do the parentheses first, and inside the parentheses I have subtraction and division. We will do the division first, so the parentheses would be 4 minus 8 divided by 4 is 2, then times 6 divided by 3. Still in parentheses, it's higher on the order of operations than multiplication and division. We would have 2 times 6 divided by 3. Then we would have 2 times 6 is 12 divided by 3. We get 4. Now we have a couple problems here with fractions. We'll still use order of operations, so I'll have to do the division before the subtraction. However, I need to change all my mixed numbers into improper fractions, so this would be 1/3 minus 1/6, and now 5 times 1 is 5, plus 2, that would be divided by 7/5. So I'm going to do this division step first. That would be 1/6 divided by 7/5. We can almost think of this right as in parentheses. So 1/6 divided by 7/5. Well, that's 1/3. Minus is here. And then we're going to take, and I'm going to keep it in parentheses just to highlight what I'm doing. It really doesn't need those. But 1/6 times, and I'm going to take the 5/7 and take the reciprocal of the second number. And so I have 1/3. And now I have 1 times 5 is 5. 6 times 7 is 42. So I have 1/3 minus 5 over 42. So to do subtraction, I have to have a common denominator. So what I'll do is I'll move to the denominator of 42. That would be a common denominator. So the 1/3 would have to multiply both the numerator and the denominator by some number that gives me 42 as a denominator. And that would be 14. So times 14 over 14 minus 5 over 42. So that would be 14 all over 42 minus 5 over 42. That would be 9 all over 42. Now that can be reduced because a 3 will divide into both 9 and 42. So we can take the numerator divided by 3 and the denominator by 3. And I would get 3 all over 14. The next one is also fractions. And I have a division, but I have parentheses. The parentheses needs to be worked first. Let's go ahead and change everything to improper fractions. 6 times 2 is 12, plus 5, that's 17/6. Divided by 10 11/2, plus 6 7/3. Now I need to give what's in the parentheses a common denominator because I'm adding, and 6 would be a common denominator, so I would have 17/6. If I change 11/2 to a fraction with 6 as a denominator, both the numerator and denominator multiply by 3. And to change 7/3 into a fraction with 6 as a denominator, the numerator and denominator multiply by 2. Okay, so 17/6 divided by 33 plus 14 would be 47 over 6. Now to do the division, we're going to change that to a multiplication, right? That's how we do division. We do 17/6 times, and let's take the reciprocal of the second number. Notice that I have a 6 as a numerator, 6 as a denominator, and they are times, so I can cancel those, divide those into each other, and so I'm going to have 17 all over 47. That cannot be reduced. 17 is a prime number. Okay, the next order of operations, we have a negative 12 squared. Now, by order of operations, the squaring must be done before the negative. So this is really equal to a negative of 12 times 12. That would be a negative 144. 6. Okay, we got a bunch of parentheses going on here, and so let's look at the inner one. We're going to have a negative 1 minus, and now I've got negative 3 minus, parentheses, a negative 1 minus, and I have 4 plus 4. So working this inner parentheses first, I get 4 plus 4, that's 8. Okay, negative 1 minus, parentheses, now let's work this inner parentheses, a minus, and negative 1 minus 8, it's going to be a negative 9. Okay, continuing on, negative 1 minus, negative 3 minus a negative 9. That would be a negative 3 plus 9 would give me 6. So that's going to be negative 1 minus 6. I'm going to get a negative 7. Next problem is going to require me substitute some values in. It says evaluate using the values. Evaluate each using the values. So I need to plug m as a negative 3, n as a negative 3 into this. So 4 now times parentheses m. M is a negative 3. And then I'm going to say minus, now n is a negative 3. Plus n squared. So negative 3 squared. Okay, that would be 4, negative 3 plus 3, because negative minus a negative is a plus 3, so negative 3 plus 3 would be 0, plus negative 3 squared is 9. 4 times 0 is 0, plus 9, I'm going to get 9 as an answer. Okay, the next one, it says convert 9 quarts per yard to ounces per centimeter. Okay, there are 32 ounces in a quart, 91.44 centimeters in a yard. So I have 9 quarts per 1 yard. And I have a conversion of 32 ounces in 1 quart. Let's just write this over here. We're not going to use it yet as part of the equation, but 32 ounces, 1 quart. That's one of my conversion factors. The other one is 91.44 centimeters in 1 yard. Okay, so, and what I need is, as an answer, is ounces per centimeter. Okay, so first thing I have to do is first thing I have to do is take a look, and I have a quart as a numerator, and I need to have, look at what I need to have. I need to have ounces per centimeter. So I need to find something that relates quarts and ounces. Well, that's right here, 32 ounces per quart. And I need to have the quart as a denominator so that it cancels with this quart. And you'll see what I'm going to do here in a second. So here quart is a numerator, and I want to get rid of the quarts, so that means the quarts that's here must be a denominator. So I'm going to put 1 quart over 32 ounces. And notice what happens. The quarts go away as a unit, so, and I have ounces as a numerator. Look, I want ounces per centimeter, so yes, I do have that set up right. So the next thing I have to do is I have to get rid of this yards, because what I need to have is I need to convert the yards into centimeters. So here's my conversion right here. I have 91.44 centimeters in 1 yard. Notice the yards that I have here is a denominator, so to get rid of that yard, I will have to multiply it by something that has yards as a numerator. So if I put 1 yard over 91.44 centimeters. That's my conversion factor switched. The yards that's a denominator will cancel with yards as a numerator. Now look at what my end answer is going to be. Ounces per centimeter. That's exactly what I want. So I have this problem set up correctly. So what I'm going to have is 9 times 32 divided by 91.44, and you can see that my units will be ounces per centimeter. And so if I do that multiplication, I should get 9 times 32 divided by 91.44. Let me put it on hold while you get out a calculator. That's equal to 3.15 ounces per centimeter. Next problem says simplify. That means I cannot find the value of n. So if you get an answer that looks like this, you've done it wrong. You're not going to be able to figure out what n equals because there is no equal to sign in it. You just have to leave it with n. So let's go ahead and distribute. I've got a negative 6 times a negative 4. It's a positive 24. And negative 6 times a negative 3n would be plus 18n. Okay, moving on to the other side, or the other one, I've got a negative 9 times 10. That's minus 90. And the negative 9 would also, or subtract 9, however you want to look at it, the negative times this negative would make plus 27n. And so now let's combine like terms. I have 18n plus 27n. That's going to be 45n. And I would have the 24 minus the 90. That would be a negative 66. And that would be my final answer. Okay, this next one is a complex fraction. And remember, the rules that I gave for a complex fraction was that any time you need to get rid of this denominator. And so what we're going to do is if we multiply both the numerator and the denominator by the reciprocal of the denominator will become 1. So I have 3u over 4. So the reciprocal of the denominator would be 4 all over 3u. Now I can't just multiply the denominator by that. I have to multiply the numerator by the same thing because 4 over 3u divided by 4 over 3u is 1. So I'm not changing the value of anything. Now look what's going to happen. And that's just going to become a denominator of 1. So basically what this is going to leave me is with u squared all over 16 times 4 all over 3u. So now this is just a multiplication problem, and so all the numerators are going to combine, all the denominators are going to combine, so you can kind of think of it as being like this now. And let's go ahead and cancel some stuff out. The 4 will divide into 16 4 times, and that would leave me a 1 in the numerator and a 4 in the denominator. This u will cancel into the u squared, just leaving me, because of u squared divided by u is just u. Okay, so, and that would, when this cancels in, that leaves me with the 1 there. So this is what I would end up with, u times 1. That's u. And the denominator has a 4 times a 3 times a 1, so that's 12. And that's my final answer. Okay, let's do the next one. Now, one way to work this is to factor out. You cannot. This is totally wrong. So I'm going to show you the wrong way first. So let's get rid of that. You may be tempted to say 3 divides into the 15 5 times. Okay? And so you're going to say this is going to be 24x minus 5. But that's not correct. Because what you really have here is you have 24x minus 15 divided by 3. Well, the numerator is in its own little implied parentheses. And so what if you take 15 divided by 3, which is what you did over here, you're actually violating order of operations. So you cannot do that. That is totally wrong. So, see, I can get rid of that. I'll just let me put on hold while I figure out how to erase it. Okay, I got it. Okay, so what you can do is one method is you can factor. Notice that I could take a 3 out of the numerator, so I could get 3. That would be 8x minus, if I take a 3 out of 15, that would be 5 all over 3. Now this is a different story. I can divide this 3 into this 3 because this term is multiplied by this whole term. Okay, that's one way to look at it. Another way to do it is to say, let's split this numerator up to its separate fractions. So that would be 24x all over 3 minus 15 all over 3. And 3 divides into 24 8 times, so that would be 8x. 3 divides into 15 5 times, so 3 minus 5. So I got the same answer both ways. Okay, let's look at the next one. Once again, you cannot divide this 3 into the 24 from what I showed you before. There is nothing I can factor out. Like here I factored a 3 out of my numerator, and then I had multiplication and multiplication. So that's not going to happen here. So really this is already simplified. There's nothing I can do. It's just 24x plus 7 all over 3. Now another way to look at it, which would also be correct, is if you break this up into 24x all over 3 plus 7 over 3, you'll get 8x plus 7/3. That in technicality is also a correct answer, but it's really not any simpler than what you started with. But I would have accepted either one of these as answers. Okay, here we have a solve, and what we're going to do is we're going to go ahead and distribute these numbers in and then try to find the value for n. Now here I do need to have an n equals, so 6 times a negative 6, that's a negative 36n. 6 times a negative 4, that's minus 24. This negative 4 or minus 4 will multiply by this minus 3, giving me a plus 12n. The minus 4 or negative 4 will multiply by this 3, giving me a minus 12. Okay, now let's combine like terms. I have a negative 36 plus 12. So the n's are going to combine, and that should give me a negative 24n. I have a negative 24 that's a number, minus a 12, that'll be minus 36. Okay, continuing. Next thing I'm going to do is add 36 to both sides. Negative 24n is equal to 48. Dividing both by a negative 24, n is a negative 2. Okay, let's move over to problem 14. Now, the way I would work this problem is after combining like terms on a side, for example, this negative 2 and this 1.5, those can easily combine. I got a lot of fractions. I'm not going to work it with fractions. I'm going to get rid of the denominator. I'm going to show you how I'm going to do that. The first thing, though, is to take, and I've got a negative 2 plus 1 1/2. So in my, let's just go ahead and work it out. So a minus 2 plus 1 1/2, that would be a minus, it's going to need a common denominator of 2, so it would be a minus 4 over 2, plus this would be 2 3/2. So what I would have is I would have 15/4 plus b over 2 is equal to a negative 7b all over 3. A negative 4 plus 3 is minus 1/2. Okay, so now what I'm going to do is I'm going to get rid of the denominators by multiplying the whole equation, or one side and then the other side, either way, by the common denominator of 4, 2, 3, and 2. And that's going to be 12. So what I'm going to do is I'm going to change the color here so we can see that. Is I'm going to multiply this side by 12 and this side by 12. And so when this multiplies in, I would have 12 times 15 divided by 4. Plus 12b all over 2. Over here I would have 12 times a negative 7b all over 3. And then this 12 would multiply by the 1/2, which would be a minus 12 all over 2. And look what happens to my denominators. Okay, so what I have is this 4 cancel into the 12 3 times, giving me 3 times 15 is 45. 2 divides into 12 6 times. 3 divides into 4, 12 4 times. 4 times a negative 7 is a minus 28b. And over here, 12 over 2 is 6. So I've gotten rid of my denominators, which is going to make this much easier to work. So if you would stay and work with fractions, there's a lot of opportunities to make errors, and a lot of students can't go all the way through it. So let's combine like terms. So if I move this 28, so we'll add 28b over on this side. We'll add 28b on this side. I'm going to have 34b, 45, plus 34b is equal to a negative 6. And now then, I'm going to subtract 45 from both sides. And I'm going to have 34b is equal to negative 51. So b is equal to a negative 51 all over 34. Okay, so now we'll continue from here. So what we can see is this actually can be reduced if I take the numerator and divide it by 17, and the denominator, that was a 34, denominator by 17, then I would get a negative 3/2. Okay, and I have a lot of interruptions here because this is parent-teacher conferences, and I'm stopping as a parent comes in, so pardon the little pauses that I have to do. Okay, next is to solve and graph this, so let's go ahead and simplify. So a negative 15 plus 6r is less than or equal to, now take the negative 5, multiply it by the 3, negative 15, and minus 25r. Okay, now let's get all the r's to one side, so, and all the numbers to the other, so I'm going to add 25r to this side, and 25r to this side. Get negative 15 plus 31r is less than or equal to a negative 15. Okay, continuing, I have, let's add 15 to both sides. So I would have 31r is less than or equal to 0, dividing both sides by 31. I would have r is less than or equal to 0. That would be a closed dot at 0, and all the values where r is less than or equal to 0. Okay, let's move on to the next one. Notice that I have two inequality signs, a greater than here and a greater than there. So this value that I have for m here is going to be between these two values. So this is actually an and kind of a problem. And so let's go ahead and simplify this. So I have a minus 6m plus 6 is greater than or equal to a minus 7m plus 10 is greater than or equal to a negative 8 minus 6m. Actually, this one's a little more difficult than I wanted to have. You could normally work these as one, like say, I have a 10 here. I could subtract 10 from the middle part, subtract 10 from this side, and subtract 10 from this side. And that would be okay. Now, what I have is a variable on all three sides, and I really didn't want one that difficult. One way that I could work this that makes it fairly simple to do is let's just break this into an and. So let's say what we have, because I said since this part in the center has to meet both those requirements at the same time, that makes it an and. So let's go ahead and just write a negative 6m plus 6 is greater than or equal to a negative 7m plus 10, and the negative 7m plus 10 must be greater than or equal to a negative 8 minus 6m. And we're going to work both sides of that. So let's just start on this other side. I'm going to add 7m to both sides. And that gives me m plus 6 is greater than or equal to 10. And the other side, I'm going to add 7m on this side too. And when I do that, I get 10 is greater than or equal to a negative 8 plus m. Over here now, let's move the 6 over, minus 6. So when I do that, I got m is greater than or equal to 4, and over here, I'm going to add 8 to both sides. And I have 18 is greater than or equal to m. So m is less than or equal to 18. So let's go ahead and plot those. It's an and, so I'm looking for the intersection. So m is greater than or equal to 4. That would be a closed dot at 4. Let's just put them above there. And I have m is less than or equal to 18. And since it's an and, the answer is the overlap. So that's what we actually want to put on the line, is the end answer. So there's the graph. And I could have written this. Notice that I could put this m back in the middle by saying 4 is less than or equal to m is less than or equal to 18. So once again, I have m is greater than or equal to 4, m is less than or equal to 18. So that would be the combined way to write that. Okay, the last problem is a compound inequality with OR. So we have two sides. We have this one, 5 minus r is less than or equal to negative 4r, and we have this side. So let's go ahead and rewrite it. Now remember, in any of these times, if I would ever divide or multiply by a negative number, I would have to switch the inequality sign. So let's go ahead and work that one like this just to get the practice at it. So what I'm going to do is I am going to add let's add an r here. So I would have 5 is less than or equal to a negative 3r plus 5. Now I'm going to subtract 5. So minus 5, minus 5. I get 0 is less than or equal to a negative 3r. Now I'm going to divide by a negative 3. And what that's going to do is that's going to switch the inequality sign because I'm dividing by a negative 3. So when I do that, I would have 0 divided by negative 3 is 0, but the inequality sign switches and I would have r. So r is less than 0. Now, or on the other side, I am going to seems like I've left a piece of this out, 6r. So over here, let's say we're going to subtract 5r from both sides. That's going to give me r minus 7 is greater than or equal to 2. Now let's add 7 to both sides. That's going to give me r is greater than 9. So we can carry that on down. So that's my answer, and let's plot it. This is an OR, so r is less than or equal to 0. Close dot. And over here I have r is greater than 9. Now notice that that does not have an equal to sign underneath it, so that's going to have to be an open dot. And that should be it.